Welcome to a lesson with Dr. Powell. Let's take a look at Green's theorem, kind of formalized formulaically. How do we get from a line integral to a surface integral as discussed in the last video? Well, we have it right here. You replace your f with df, and then you wedge dx, and then you g dg wedge, and then h dh wedge. Doing so between differential forms, actually, from this differential form to this one, is called taking something called an exterior derivative of differential forms. We don't really go into that, but nonetheless, this is the way that we take this and we transfer it to this, using the idea that df itself is the rise, where these are runs of the function f here. If we think about taking the derivative of f as fx, fy, fc, and dotting here, and we're getting this. So basically, you're taking all of this and wedging it on, and you take it and you wedge it onto dx here. If this was df, and you wedge dx, notice that when you do that, only one thing one thing goes away. Dx wedged with itself goes away, so you're just left with things coming from here. So, but then you do that for each one individually. But in this way, we actually get an equality, and the reason for why this works can kind of be seen, at least in a motivation type example, in the last video, where we're essentially, notice how we have like an fx, fy, because we're taking the derivative with respect to something. Then we can integrate the wedge product right here. Orientation operator just helps us keep things straight on a curve. Like if one thing is before another thing, then maybe you have a negative direction on the top and a positive direction on the bottom, or vice versa, or something like that. So the wedges kind of keep that straight, and you can turn the line integral very nicely into a surface integral. And we're going to be looking at some examples of this in coming videos. Thanks for watching.